And we are live. Hello there. Thanks for tuning to Exit Island. My name is Abatan Sheriffdeen, data analyst on Upwork. So I've had major success on the Upwork platform. So over for the past 2, 3, 4 years that I've been in the business of freelancing, and this is this is the first day actually. This is 2023. I'm going full time, and it has been really amazing and challenging to get it done. So if you're looking to success, yes, you can also go full time. This is my first year going full time, and I must tell you, it's really a whole lot of work behind it. So if you're looking to start your own freelancing business also, you can check out a course by my coach. Of course, I have a coach or two stuff about freelancing before I decided to go full time. So you can check out his course in the YouTube description. The name of the course is Freelance Client Magnet Course, which teaches you how to become a successful freelancer on Upwork, Fiverr, LinkedIn, and remote job website. Also, you learn how to freelance using your social media accounts to attract potential clients to your freelancing business. Don't forget to check out that course in the YouTube description. Don't also forget to support this channel by giving this video a thumbs up and subscribing to this channel. That shows you support what I'm doing. So basically, what I do currently now is I live stream and also share some videos once every day, every now and then. Also, I make videos and to build a learning journey. I'm trying to upskill myself in SQL, Python, Power BI, and Excel, using other resources also aside the Datacamp resources. And I'm currently on a 1 year subscription on Datacamp, and I'm trying to maximize and make use of it to the best of my ability. That's why I'm making sure to show up every day consistently. So, but today I would like to review. Normally, when I log into the Datacamp dashboard, I have some weak areas to review. So I would love to review these weak areas first, and I'll jump to this lesson. And I'm actually finding a couple of lessons challenging in this data manipulation part. So I'm trying to today I'm going to do something different. I'm going to use other resources to try to understand that concept pretty much well before I move away from this particular section. I don't want it to be something that I would later find it difficult to work with when I actually eventually work on real life project or when I actually work on the project part of the course. You get it now. So I try to make sure I understand it and I can explain it better to somebody else. That means I actually understand what I'm doing. I don't just want to rush through the whole course and move like that. So don't forget to support the channel by giving this video a thumbs up the channel. And also don't forget to check out the freelance plant magnet course by Benga DB, my coach. You get 10% off when you use the link in the description of this video. Make sure to check it out. So let's review today's section weak areas first. I'd like to review these weak areas that I have, and then I can continue and do some other stuff today just to make sure the knowledge is there. So actually rain is falling, and in my country, even when rain is not falling, the network is a big issue. Now imagine when rain is not falling. So that's how what we deal with here in Nigeria. I don't want to say in Africa because there are some African countries with super great network. Okay, let's practice introducing inner joins. So, okay, it says the songs release and listening tables are shown below. The release table contains exactly one release date for each song in the song table. The release table contains exactly one release date for each song in the song table. The listening table contains information about listeners and all the songs they have listened to. Which of the following tables have a one-to-one relationship for each song in the songs table? Hmm. So it says the release table contains exactly one release date for a song in the song table. The listening table contains information about listeners. That should be. I know it's song and release because the listening table immediately. I say the listening table contains information about listeners and all the songs they've listened to. So from the listening table, you're going to have multiple song ID. But it says there the release table contains exactly one release date for each song in the table. So one to one relation will be in the release songs and release table. So you are working with the venues and cities table. Select the code to return this output. If I say this output, venue, okay, name and venue name. This is the name, probably the name from the cities table, and the venue, the name from the venues table. So select cities as name, city name as name, and venue name as venue name. So which ID are they joining? City ID, okay. Inner join, inner join venues on cities ID, okay. This is not correct. It's between this first option and second option. Name venue name. City name as city name. This is the correct answer. Citizen. So this first one is the correct answer. It's saying city underscore name. So they all are the same thing there. So shown below is a preview of matches and match captains tables from a database about the Indian Premier League, a professional cricket league. So shown below is a preview of the match and match captains. Let the code return the output. Okay. You're saying not equal to where the match ID is not does not equal to the ID from the match table is not equal to the ID of the captain's table. Is that correct? Let's see. I think the ID are matching here. 87, 88, 89, 89. So that should be the correct answer. I guess that. So that was what I could differentiate there. So a query has been started to join the venues and cities table from a database about the Indian Premier League. Okay, select as we select star from join on. So that's quite straightforward. Let's have Nigerian cities that stay on that website. So I think I've seen this question before, but I can't see the table. But the answer is many to many relationships. So D25, let's go. Let's go consistently for the next. Looking forward to day 50. Let's see day 50. Oops, what was that? Let's see day 50. Now let me review this last part one more time. Oh, the rain has stopped, so my network is super fast back. So the following is not true about correlated subquery. This correlated subquery, I need to go back to the lesson one more time and actually understand it better. So they usually reduce the length of your query. Not true. They offer an alternative to complex joins. This is true. They slow down your query processing time. They require at least three tables to be present. That's not true. They usually reduce the length of your query. That's true. They offer alternatives to complex joins. True. I'll go for that last one. They slow down your query processing time. They're actually fast. The queries of query are actually fast. So this is an example of a correlated subquery. You have access to a table about bike trips in San Francisco. I love San Francisco. Shown below. How can you view stations with total trips lower than average using the next step subquery? Here is a preview of the trips table. Oh, well done. So you have access to a table about bike trips in San Francisco, shown below. How can you view stations with total trips lower than average using going to view station with total trips lower than the average? So we need to see calculate the average first. So when you select, this one will definitely select. Oops. So okay, select star station from from this. Okay, this is the from select star station, comma, and select. I want to select another stuff. Hold up. Having counts. Okay, this see this count here. This count should give us the expo here. Group from trip, group by start station, having counts. So I know that definitely the first stuff is counts. So select start station, count the rows. So we're going to count the number of trips recorded as trips. The number of records in the station table as trips. From trip, group by start station, which is normal because we're having an aggregate function immediately. So having counts greater than, so we want to get the average of the, so this trips is going to calculate those trips. The amount, okay, count as trips, we count the total number of trips there, but we want to calculate the average trips. So having count average, select average count, and say, hold up, hmm. There's a subquery here also. Hmm. Hold up. If my having count as less than this, so what should be here? So open will be here. So I'm thinking this is wrong. This is tricky. Consta. Oh, oh. I misplaced this for each other. So the start station is supposed to be here. The average is supposed to be here. That's my mistake. I knew that was close. I started at the start station. Number of rides. I ended at the start station. This is the preview of the trip table. For each station, what is the difference between number of trips started at the start station and number of trips at the end station? Below is a preview of the trip table. Mm, the difference. The difference in number of trips started at the start station and number of trips that ended at the start station. Okay, start station, end station. So we have to have the start station first. Select start station, count start station as start trips, count start station minus select counts from trips as C1. This is a subquery. I want to subtract from this subquery. This one is N. So our trip difference is select count star from trips as C1, where C1 where trips C1 dot end station. This one is as C dot start station. Okay, this will be where C dot start station is equal to C1 dot end station. Because this is our T table also from the outer query. Now group by That's to go by start station, which is sure. Go by start station, which is the result of this here. Order by start station descending. Let's check that's correct. So that's quite straightforward. Usually I'm minusing minus count start station minus this count of each rows from tip, where the start station is equal to the end station, where the both records are equal to each other. Oh, cool. Okay, understood that. So now the one I filled earlier. Now you have to count. This is the width as no. This is the CTE calculation. So the most popular station to start a trip, also the most popular station to end a trip. Can you set up a join? Can you set up and join a CTE, like common table expression, the trip table to get this result? Here is the preview of the trip table. So start date, start station, end date, end station. So this will definitely be with S as with S as select start station, count start date as starters. So with S as so this our subquery will be our S query. So we have select start station. This is start station. Count start dates. We're going to count each rows. The start date as starts from trip. That's definitely from trip. From trip, go by start station. This is quite understandable. Straight to the point. Selecting the start station and counting the number of rows in the record from trip, then grouping by start station. We need to count how many trips was occurred or was done in that start station. So let's say the most popular station to start a trip, also the most popular station to end the trip. So I want to count this for the start station. Now I want to count for the end station. So select end station. So we've not alias that end station table as C. So with S as comma, there's also be a comma here. Select these as start from group by start station. Then select T dot end station as station. Count the end station. Count the end dates. This we're going to count the number of trips from the end station, the number of days there, understood as ends, comma, S dot start. Hold up. Select the start table. Okay. Now I'm going to select the start table from the S subquery, rather from T plus T. So inner join. Now the inner join on T dot end station and S dot start station. That should be S dot start station. We want to know whether both records is both are the most popular station to start a trip. Maybe where the trip was started is also where the trip was ended. So go by station and start. Check. Correct. So I know that will be correct. Yeah, I was pretty sure of that. So I cities are much more easy to interpret. Cities are interesting because each subquery runs separately. And they are interesting to know. Okay, can you use a nested subquery in form to extract the two hottest months from a data set or weather in San Francisco? So here is a preview of the weather table. So we have the date record, we have the maximum temperature. So we want to use a nested subquery in form from our form clause to extract two hottest months. Wow, from a data set of weather in two hottest months. So we need to extract the month and we look at the maximum temperature above, probably above 35 degrees. This is in Fahrenheit. Maximum temperature in Fahrenheit. Okay, let's give it a shot. Select MO. What does MO mean? Okay, I was selecting MO from here. Select MO from as minimum height. Mean height. We have another form here. This is complicated. So let's give it a shot. Select MO. I need to go back to, oh, got you. The MO is coming from here. The month is coming from here. So select, I need to come back here. Oh, I don't want to go. If I select, it's going to start select from here. MO from, so the form will be here. So it'll be from there. Hold up. Mean I, mean, this is saying mean. Let's see. Select MO, average maximum temperature as mean I, correct. So it can also alias it as mean. So that's average. From the select, this will be select, extract the month from date as MO. We're extracting the month from this date record as MO, comma, select months as MO, maximum temperatures from S1 as S, hold up, from S, so they have renamed the table as S, from S as S, so this has been named as S, go by MO as S1, order by minimum temperature depending. Let's see that. Let's give it a check. Ooh, oh, from weather. The table is named weather. Oh, from the weather table. That is my mistake. The table is named actually weather, so I didn't pay attention to that last part of the table. That's good. Now, this one is select start station, count trips. We are going to count star. So when we count star here as trips, select start station, count star as trips from trips. Now, once you get select start station, this is start station here. I didn't do it very well that time. Count star. They say you have access to a table like your bag. How can you view station with total trips lower than the average using lower than average? You want to get the total trips here from this query here. That's going to give us the total trips. So select start date from here, then count star. We're going to count the each rows from trips. Go by start station, having counts. Now this is where you get tricky. Select better than the average. Select average CR as this is CR as average as CR from now. Select this is the end station. Select end station. So end station as count the rows from the end station. Okay, as CR from trip. Goodbye. The goodbye coming in here. Where is it coming from? Oh, I don't need the end station there. Mistake. I need the start station there. Also need the start station there. So then start station. So you're going to calculate start station, count star as CL. So when I count the start station one more time here, and I count number of rows from the start station, go by start station. Since we have start station here, so I need to have to make sure I'm selecting the start station here also. Then this is my as my subquery. So this is my subquery. Now from here, I'm going to select average CL. So this is CL that has been named CL. So the select statement here is going to select the average of that CL. Since this table has been named CL, let's calculate the average. So once it's calculated the average, this will be fed. This average is going to return a scalar value. Now understand better. This average is going to return a scalar value, which will now be fed to this outer query. So having counts of this scalar value greater than or less than the total trip. So that should be correct. Yeah. Now I understand it better now. That is quite interesting. Now I did a mistake earlier here. I almost got this one too, even though the table that is returned is pretty small. But I did mistake without referencing the weather table, the name of the actual table from the start. But I got to that. This MO is coming from here. So I have to come back to this place. Let MO hold up. If I could fill in this section here, I can get this section here. This section is quite this is just a select clause here. So select MO as mean I. This one is as average. So once you select average there, average calculation there. Once you get the average MO, this one is select. Let me bring in select there. You are select extract month. So the month that is extracted from here, from the date record here, from the date record here, as Mo has been extracted, alias as MO, then the maximum temperature for that month from, that's the mistake I did, from the weather table. So this table itself is named weather table. So if you can get the months as MO and the maximum temperature for that month from the weather table as our X, then we can now feed that back into this select MO, which has been calculated here, and the average of that maximum temperature. You can see the maximum temperature here, the average of it, the maximum temperature calculated from this subquery here will now be picked up by this average maximum temperature here as MO. Then this will now be grouped by this whole query here will be grouped by MO that has been selected there. So if that is selected there, so from our form clause, the form clause can return two tables. We're going to return two columns, which is the MO and the average temperature, which has been named as what? Mean I. So the outer query will now select the MO and mean I from this subquery here, which will now be ordered by that mean I temperature descending bool. Yeah. I hope that's clear. That is a pretty tough thing to understand. A pretty complex technical stuff to understand, but I was able to figure it out. Yeah. I understand. Now the question is interesting, but man, if you can't think of doing this kind of calculation to solve your real world problem, that's gonna be challenging. So day 25 done and dusted. I'll just continue from here, but I want to do something different. I'm having it finding it difficult to understand this last part of this section, this data manipulation in SQL. And that's one thing I think every learning person should understand. So if you don't understand the concept, that doesn't mean you should just go over it. So I have to go back here. So I want to do this over clause one more time. But this time around, I want to use external resources to implement to compound the knowledge better. So what I want to do is I want to now understand the Windows function.
Great job. You now have experience transforming data using simple subqueries, correlated sub.
I understand what the Windows function is doing. I want to search for it better somewhere else. So I could say, so I want to use SQL over Windows function. I'm going to use this double quote to search on Google for exactly that keyword. So it can take me to a resource that explains that keyword to me perfectly well. So I hit enter, I could see. So this double quote is going to make sure this exact word is searched for in the Windows. So how to use Windows function with examples. I just want to read this part and see if I can get like a syntax from Windows function. Let's go over the syntax pieces by pieces. So the function, expression, then the column is a window function such as sum or rank. So the over specified that a function before it is a window function. Oh, so the over clause actually itself is not the window function. It just used to specify that the function before it is a window function, not an ordinary one. So when the SQL engine sees the over clause, it will know that the function before the over clause is a window function. So the over clause has some parameters which are optional depending on what you want to achieve. The first one being partition by. Okay, I've come across partition by. So the partition by divides the result set into different partition of windows. For example, if you specify the partition by clause by a column or columns, then the result set will be divided into different windows of the value in that column. This expression list in the partition by clause is expression column name, okay, which means that the partition by can have an expression, a column, or more than one occurrence, or an expression or a column which must be separated by a comma. For example, partition by column 1, column 2, okay. Let's understand them. The next parameter order by, okay, order list, okay. But I want to see an example of the Windows cost function, okay. Okay, this is an example here. I think this is quite simple. So how to use the Windows function example. Let's go over an example of how to use a Windows function. Say for instance, you want to compare the minimum score and the maximum score for all the records in the table we created earlier. You can do that using a Windows function. Remember that not specifying a partition clause in the over clause will cause all windows to span through the entire dataset. Okay, let's see. So as you can see, we have the minimum and maximum salary across the entire dataset. The minimum and maximum salary. So okay, we have a student ID here, the student name, the departmental name, the score, maximum score, and the minimum score. Yeah, we can achieve the using software, we can achieve same thing. This is quite simple. We are select the maximum score from the student score. So if you have the student ID, the student name, the department name, and the maximum score. So select star, select maximum score from student score, maximum score. So this way is going to select, it's going to return one query, maximum score. The maximum is going to return one set, it's going to return one result, maximum score from the whole score record here, which is 90, and the minimum score is 55. So even though we are returning all the whole records from it, which is wrong actually. But if you use over, so see maximum score, minimum score, over as maximum score, over as minimum score. Okay, that's quite simple now. I understand that over. Now, how to use a window function with partition by. Say for instance that you want to split the data set into different partitions. Then you want to compare each record in each partition with an aggregate value or a calculated value of each partition. You can specify the partition by clause in the over function. This is where I don't really understand from the Datacamp explanation. Let me see if I can get the understanding here. So for example, in this example here, select star maximum score. This is going to give us the maximum record or score in that particular column. Over, even though you specify over, you can just say over, open bracket and close the bracket. But now we have introduced partition by. This is going to partition the maximum score by the department maximum score. You can see that we have different departments here. We have biochemistry, computer science. So the maximum score, oh, now I'm getting it. It's going to look instead of returning the maximum score based on from the for the whole score field for the score table or for the score column rather. It's now going to go to the department that we specify and return the maximum score for each department based on the score records. Quite interesting. This one I don't understand this. I'll check it again. Another thing I don't understand there is this sliding function, this sliding part. Okay. I don't understand that section too from here. But I understand this partition by. It's partition by another column. So it's going to filter. So when you see that now after partition by filter, it can then calculate the aggregate function for each record in different departments. Okay. So around hold up, maximum score over partition by department and particular score, round average score. Okay, we are now rounding it again. So you just pick this same calculation. No, this is another calculation. Average round. Okay, it's also normal round now. Round average score over partition over clause over middle function partition by the particular name two decimal places as departmental average. Oh, so it's now calculate departmental average based on the department. So you look at the biochemistry. So every record in biochemistry. This is the maximum score of this guy, which is 85 for this person here, for that department. It's only going to return that maximum score for the department and ignore the so now the average is now based on what? Based on this for that department, this plus this divided by 3 is going to give us this average. Oh, cool. Average score. Now we just calculated another calculation here. Average score, average of the score column, but partition by departments, just handed it to two decimal places. Okay. So other examples of Windows function. You can see from the above image that the aggregate function maximum and average is calculated for each partition. That is for each department that we use. We can also use maybe another category. Oh, I got it now. So let's go over some of the common Windows functions you will work in SQL. How to use the row number function. So use row number to assign serial numbers to records in a window. Say you want to assign serial numbers to the record in a partition. For example, we want to add row numbers to data set based on their names. So you see, you use row number to assign serial number to records in a window. Say we want to assign serial numbers to the records in a partition. For example, we want to add row numbers to the data set based on their names in alphabetical order. You can do that using the following code. Based on their name, let's see, G will come before H, which is correct, but A will come before B now. So it is using the first letter of the alphabet to grade them by their name. Okay, so let's start row number over order by student name as name serial number. Okay, order by clause. The order by clause just arrange. So the order by clause arrange will just be a rank. Well, why? Because it's using row number in the first. We can also use a rank rank function here. So I learned that from the Datacamp resources to aggregate a data set. Okay. We can also use rank here. Like so, okay. Rank, as the name implies, it lets you rank observation in a window, but with gaps. Let's see what this means. So let's start rank over because it is using department. Oh, no, it is using department rather than the student name here. Rank over partition by department order by score ascending. Wow, this is quite different from what I know. Partition by partition by here, which is going to partition rank the names by the score. To rank over partition by department, partition by department, but order by the score descending. As you can see in the above code, the result saying was partitioned into different windows based on the department column. Then we use the order by clause to store the student record based on their score. Okay, order by score based on their score in descending order in this partition. So that we apply the rank function. 85, 80, but this is 90. 90 got the partition a rank of 1, 85 got a rank of 1. Now, concerning the graphs, as you can see in the highlighted part in the above image, two records in the computer science department have the same score, 80, 80. Yes, this scores both to be ranked with the value, so instead of one being ranked to another 3, so it doesn't know how to handle a tie, basically. You can write this scenario using another Windows function called different rank. Wow, let's not go there. I need to understand one function at a time. So now it is ranking. Oh wow, now understand it is ranking each department. You can see rank over partition by departmental name. It is ranking for each department, for each score by each department. This is 85, second, third for the biochemistry department. Now for the computer science department, this is the first rank of 1, then rank of 2, which is normal. It's going to skip 3 because it is saying 2, and we can still avoid that with another function. So I'm curious about all these guys which it say. Over just close on bracket is normal. Now if you partition by a particular column, that calculation will be aggregated based on that column. You now put a rank function there and order by. So when you put a rank, you also order by a particular column, which is normal. Okay. I think I have a good answer. I'll still go over these resources one more time. Well, I think that was all to learn for today. But off camera, I will try to complete this section today once and for all, and just complete it. I'll also end the live stream now. So thanks for staying to the end of the live stream. As I said, 30 minutes, 45 minutes, 1 hour. We are 50 minutes into the live stream, and I have to end it now and go off camera and patiently complete what I want to complete in this section. Definitely tomorrow, I'm going to be starting a new chapter entirely from the course. Thanks for staying to the end of the live stream. If you found this useful video helpful, give it a thumbs up. Don't forget to support the channel by subscribing. I can use the link in the YouTube description to also subscribe to support the channel. Bye for now, and I will see you tomorrow on day